All right, guys, let's look at lesson 4, which talks about percent error. So first, we got to talk about accuracy and precision because that's going to become a crucial component of the percent error. So accuracy is how close to a measurement is to the accepted or true value. So that's the same as saying, how close are you to the right answer? Precision is how close a series of measurements are to each other. So if you have precise measurements, they are all really close together, but that doesn't mean that you have accuracy in your measurements. So let's look at an example. The easiest way to describe this is to look at a bullseye scenario. So since all of these arrows have hit the target, the bullseye, they're all close together, they're considered to be both accurate and precise. Accurate because they hit the target, what you were supposed to do. They got the right answer, which means that you're supposed to hit the bullseye. And precise because they're all close together. These are accurate because they're close to the right answer, but they're not precise because they're not really close together. These arrows are precise because they're close together, but they're not accurate because they didn't hit the target. These arrows are neither precise nor accurate because they were not close together, so they're not precise, and they weren't close to the right answer, so they're not accurate. So let's look at an example that looks at student data. So these students were asked to determine the density of sucrose. Sucrose has a density of 1.5 grams per centimeter cubed. Which student is more accurate? So when we're looking at accuracy, we're looking at the student that's the closest to the correct answer. Student A's average is 1.57. Student B's average is 1.51. And student C's average is 1.70. The student who had an average that was the closest to the actual density of sucrose is student A. So student A's measurements would be considered to be more accurate. Now let's look at percent error. Percent error is your measure of accuracy. So that means that's the percent that the measured value is off from the accepted value. So the measured value is what you get when you do an experiment. So these would be the masses or the volumes or the lengths that you get. That's your measured value, what you yourself as a scientist measured. Your accepted value is what you should have gotten. The right answer, a known answer, a consonant, something along those lines, something that you know that is true. So what is the formula in table T in your reference table? Okay. The formula is percent error equals your measured value minus your accepted value over your accepted value multiplied by 100. Now, if your answer is negative, that means that you got an answer, you measured an answer that was less than the accepted value. If your answer is positive, then that means that your measured value is greater than your accepted value. Let's look at an example. A student determines the density of a substance to be 1.40 grams per milliliter. Find the percent error if the accepted value of the density is 1.36 grams per milliliter. So with all of these kinds of problems, the first thing you're going to do is you're going to want to get your equation. Here's my equation. The next thing you're going to want to do is you're going to want to plug in what you have. So my percent error is going to equal, first, my measured value. My measured value is what the student got when they did the lab. So that's 1.4 grams per milliliter. From that, we are going to subtract what they should have gotten, which is the accepted value or the correct answer, the known answer, which is 1.36. Then what you do is you take that total, 1.40 minus 1.36. You're going to divide that by your accepted value, which is 1.36 again, and you're going to multiply that by 100, and you're going to get a percent. So when we plug this into our calculator, we are going to get a percent error of 2.94%, which is not that bad. Let's look at a practice. Remember, with these practice problems, I want you to try these. So pause your video, try this on your own, unpause your video when you're ready to walk through the answer with me. Great, well, welcome back. So what is your percent error if a student measures an object to be 56.2 and the actual length is 56.9? So we need our equation. To that equation, we are going to plug in our percent error, which is 56.2 is our measured value, minus our accepted value, which was 56.9, over our accepted value, so divided by 56.9 again, times 100. When we plug this into our calculator, we get a negative 1.23%. It's negative in this case because our measured value, right here, is less than what our accepted value was. So let's do a check your understanding. Remember, in order to get credit for your homework, you need to do this. So, let's look. In a lab, you are told by your teacher that the actual amount of sugar in a can of Coke is 39 grams. You experimentally determine it to be 37 based on your own data and calculations. What is your percent error? We'll go over this question first thing tomorrow morning.